All right, welcome back. Let's talk a bit more about the hash function part of our hash table. So we'll be using hash functions to convert keys, like the string pink or cyan, and turn that into a valid array index, a small number. But hash functions have uses all over the world of the internet and privacy and just computing in general. So on Wikipedia, the first use that is listed is indeed hash tables, what we're talking about. But they're also used to help protect your data, to store your data, to authenticate you when you log in on a website. They're used in cryptocurrencies and cryptography in general. There's many types of hash functions, including a subgroup called cryptographic hash functions, which are crazy, the math and the science behind them. This is the stuff where I said there's like teams of researchers working on them. Cryptographic hash functions are a crazy branch of cryptography, which is already a crazy branch of science. It's fun stuff. I have a course that, am I allowed to say that? I may or may not have a course on this topic and on cryptocurrencies and how it all fits together. Okay, I hope I don't get in trouble for that. Anyway, what we're talking about are just basic hash functions. And the definition of a basic hash function is just a function that takes data of arbitrary size, whether it's 1,000 characters or a million characters, and it's going to spit out data of a fixed size. It's going to map an input to an output of a fixed size. So for us, let me just show you an example. This is in Python, which I know a lot of you probably don't know. This is not a Python specific course. That's not important. Languages like JavaScript actually don't expose a built-in hash function, but Python does and some others do. So I'm just going to use this here to demonstrate. This is one type of hash function. There's many implementations, but this one allows us to pass in some data, like let's say hello with an exclamation point. When I hit enter, I get a number. I'm not going to count the characters or the bits, but of this size. And I can do it again and just change something slightly, like make it capital H. And I get a number of the same size. It's shifted over because this negative sign was there. But if we look at the same number, it is the same number of characters, but it's totally different just from changing that H. But I could do a single character like A, and I still get this really long number. Or I could do a super long string that's much larger than that number, and it's going to be condensed down to this. Now, a couple of things that we should talk about. One, so this is a fixed size. This is similarly sized data no matter what the input is, and that's important. The other thing that I want to talk about is in most cases of a hash function, we can't work backwards. This is actually meaningless on its own. If all we have is the output, this is usually a one-way function, meaning that I can't just take this and figure out exactly what generated this number. So this hash function is generating pretty large, well, relatively small in the grand scheme of things compared to other hash functions, but for us, it's too large. We don't want to store numbers, at this index in an array, because then we're going to have a ton of empty space in our array. We want to, store stuff in an array of like 200 or 20 or even 10 spots, 10 elements. And this is like, what, trillions? I don't even know. More than trillions, probably. So we're not going to use this hash function. We're going to write our own simple one. But let's talk about what makes a good hash function. So first up, it needs to be fast. We don't want to spend forever hashing something because when we insert something into our hash table, it needs to be hashed. But also, when we go and fetch it or update it or remove it, every time we try and access it afterwards, we still have to run that hash function again. Right? I have to say, hey, what's the hash of pink? Then that's going to give me a number, and then I'm going to go to that number in the array. And then if I'm trying to update pink, I'm going to say, here's pink, what's the hash? So we want it to be fast. We want to make sure that it's relatively random, or random's the wrong term. We want to make sure that it distributes things uniformly so that things don't cluster. We don't want a dumb hash function that's always going to just give us the middle of an array or position 0. It's useless if every element is stored at the same spot. Now, we might have collisions, and we'll talk about how to handle that. We might have, if we're only storing things in 100 spots in an array, if we're storing like 500 things, we're going to have to share some cubbyholes, some elements there. And that's okay, but we want it to be pretty evenly spread out. And then lastly, we want it to be deterministic, and this is really important. It means that every time we pass in one input, we always get the same output. It's determined that we're going to get the same output. We don't want to we don't want there to be any uncertainty or multiple answers or outputs per one given input. So we want the same input to always give the same output. So let's just quickly run through those. Here's an example. This is a bad example, which is why I wrote non-example, of a slow hash function. We don't want this. All that it does is at the beginning, it loops 1,000 times, 10,000 times, and just prints something out. And then it does the hashing. All right, that's silly, but we want to try and keep things quick and fast. We don't want to have to loop a ton of times. We want something that is constant time. So we're going to write some of our own hash functions in just a bit, but keep that in mind. We want it to be fast. We want it to distribute values uniformly, so not like this, which just gives 0, as this is a valid hash function. If it meets our definition, it takes an input of any size and it maps it to an output of fixed size. It just maps every input to 0, which is not what we want. And then deterministic. So this also is not a good one because it is non-deterministic. It involves a random number, multiply it by 1,000, and then floor that. That's not good because that's not going to give us the same output every time for the same input. So in the next video, I'm going to show you a simple hash function that we could write that will work with strings only, but it meets some of these criteria, and then we'll try and tweak it and make it better.